This is Anusha. This is the second video of the cab booking analysis using MySQL. For the introduction, problem statement and data overview of this project, please go through the first video of this playlist. Today, in this video, I will be showcasing MySQL query tuning techniques by exploring the following analytical questions. Before querying, we will take a look at the data types I used for the columns present in the data. So here you see for the pickup date time and drop off date time, I have used the date time only. But for the pickup location ID and the drop off location ID, the values are from 1 to 260. So we already know the range of values. So I have given small int unsigned. So the small int takes only 2 bytes of storage. So next for the trip distances and the fare, I have used doubled because it is very fast and gives hardware accelerated calculations for aggregations. And then when I come to trip time int, when I have checked the minimum and the maximum value of the trip time, and then according to the values I have decided the int as the data type, which takes 4 bytes as the storage. And then for the pickup j and data type, these are the categorical values. I have given them enum data type because enum is ideal for low cardinality text fields. So if we consider this column where the day type is enum of weekend and weekday, it would take approximately only 19 MB. But if we have used the varchar, it would approximately take 140 MB for 19 million rows of our data. So here even for the location ID I have used the small int, again it is from 1 to 260, and for the borough and the zone I have used the varchar with these values. So I have calculated the maximum and minimum length of the borough names and zone names and then decided with these numbers. So here also using text will degrade our performance because text is usually for the unstructured data. So I have used varchar, and even for text it is not indexable. So varchar works better here. So why is it that we are concerned about the data types? Because the smaller types lead to faster read and write and efficient joins. It minimizes disk usage and it helps in scanning quickly and good for indexing. And then it is efficient for aggregations and it is also quick for backup and recovery. So next we'll go through one by one the analytical questions we are trying to answer. So first we are looking at the top 3 driver pay for each day. Each day in the sense from Sunday to Saturday, all the days of the week. So here I tried to retrieve the top 3 driver pay with respect to each day using this subquery, and the query ran for 2 minutes 59.64 seconds, approximately 3 minutes. So the same query I tried to run with the CT. So again it took me around 2 minutes 56.95 seconds. Yes, so it is only roughly 4 or 5 seconds of difference. Here I am not given, but I have used explain, analyze, and try to understand how the query is going on and how many rows are processed at a time for each operation. So after this, now we can see they are taking approximately 3 minutes. So I have tried to rewrite the query. So here what I did in the previous queries, I have selected the star. So the next query I decided to select the only needed column. So I selected the needed columns using CTE, because with CTE we got some 2 minute 56 seconds. So after using selecting only needed columns, I got 2 minute 48 seconds, roughly 8 to 10 second 10 seconds difference in the execution time. Next, the same query, after selecting the needed columns, I decided to filter early before windowing. So here you can see, so here what I did is I have filtered some values before the window is selected. So here what I did is I have selected driver pay is greater than 10, so that some number of rows can be avoided while matching. So driver pay greater than 10 is a broad condition for filtering. It likely matches millions of rows. I would try to find an optimal value for filtering condition to reduce the number of rows to be processed. So in the next query, I have checked the distribution of the driver pay, and then I set the driver pay is greater than 100. And even in the result set, if you see in the previous query also, all are above 100. So I have decided to give this condition. So, and using this condition, when I check, the execution time is 39.82 seconds. So the initial query execution time of ours is 2 minutes 59 seconds. So roughly it is 180 seconds. But the query execution time we got after rewriting the queries is 39 seconds. So I improved performance by 78.26%. Means my query is now running 4x faster than before without adding a single index. Now we'll check another question. It is finding top 5 pickup zones by average fare per mile. So here when I tried to calculate the average fare per mile, so I have calculated here, I have written the query in a common and intuitive way. So I have calculated this, and I have joined the table with the location lookup table, because we need readable zone names like this. And this normal query took 2 minutes 37 seconds. So here this is the summary of the explain analyze, which I got explain analyze with this query, so which I summarized like this. So it is taking these many seconds, and these are number of rows processed. Here you can see for the joining it is taking 20 million rows, and here also it is scanning the whole table. So in the same in the next query, what I tried to do is I have tried to group these values before the joining. So that's what I did, and so because I have grouped the values before joining, I have reduced one full table scan before only, because here aggregating we have only 260 groups. So first we have done the aggregating on the groups, and then we have got the result set, so which has reduced the table scans or the number of rows processed. So before our execution time was 2 minutes 37 seconds, now it is 1 minute 12 seconds. So this is how the rewriting the query um, by logical design will reduce the execution time and improve performance. Next we'll see which pickup zones have the longest average trip time per mile. Again, I have written in the common intuitive way. So I have calculated the average trip time and then joined by the location table to get the readable zone. So again it is almost 2 minutes 37 seconds. Here I have seen how many rows are coming after group by, so it is 258. Here you can see this is the explain analyze summary. So here again these many rows are processed. But I tried to write the same query using a subquery, which drastically reduced my execution time. Previously it is 2 minutes 37 seconds and it came to 59.12 seconds, and when I used it with CTI it is 58.88 seconds. So next what I did is I tried next we'll go to the next question. It is top 10 pickup drop off route pairs. So I wanted to see the top 10 pickup and drop off pairs. So I have again written in the normal way. So retrieved all the columns and then joined with the tables and then grouped, and we got the results. Here I can see most of the pickup and drop off zones are in the same borough, same zone, I think so. So we got like this, except few where it is from South Zone to JFK Airport. So this query took me almost 7 minutes 23 seconds, which is a very huge time because it is scanning and then again joining with these many rows. So it is taking a lot of time. So I again tried to do with CTE, and when I tried to do with CTE, where I have grouped by before only, aggregate I did before, so it is 1 minute 3.58 seconds. Here this is the query analyze summary, using which you will be able to decide next what can be avoided. Like here you can see like how many groups have been formed, how many rows are processed. So next we'll the same top pickup and drop off route pairs. Now I calculated using indexing. So I created the index on this table using for PO location ID and drop off location ID, and then I have given the same query like before. So after using indexing, you can see the execution time is 37.84. Previously it is 1 minute 3 seconds, now it is 37.84. So here you can clearly see in the execution summary, it is scanning using the index, and it drastically reduced the time taken. So, but there is the time is also taken to run the index. So is creating an index worth it? If you run this query or similar queries very often, then the upfront cost of creating the index pays off by making subsequent queries much faster. Indexes are especially valuable for recurring analytics, dashboards, or reporting tasks. If fast results matter, investing time in indexing is justified. So index also takes time. So if you want to run or create an index, it's better you do it at night or low traffic times. When is indexing might not be worth it. If you run only queries one at one time, then indexing might not be efficient. If your table is frequently updated or loaded in batches, then also indexes can slow down the writes. And if your server has limited CPU or disk bandwidth, then also index creation might degrade overall performance temporarily. So in general, indexes reduce full table scan and enables faster grouping, filtering, and joins. Here, explain or explain analysis, analyze, help debug and optimize query, thoughtful aggregation, join logic, and understanding data cardinality will help you write efficient queries. So, in the next video, we'll be seeing how we can create useful reports using the data. Thank you.